Hello. All right. Today we are going to learn about Pascal's triangle. These notes are not going to be long. If you'll notice, the first thing that I have up here are the notes that we just did the other day when we expanded with the binomial theorem. Okay, well, let's say you're taking the PSAT or the SAT and don't happen to have a calculator or whatever the case may be. You can actually find these same numbers, these combination numbers. When we did the NCR, you can actually find these same numbers with what's called Pascal's triangle. So what we're going to do, hold on, let me get my computer ready to go, is we're going to create what's called Pascal's triangle. And we're going to make a triangle, and we're going to make it out of numbers. Okay, so we're going to start with the top of the triangle. The top of the triangle is going to have a 1. All right, so the top of the triangle is going to have one number. And as we move down this triangle, the next row is going to have 2 numbers, the next one's going to have 3 numbers, the next row is going to have 4 numbers. So this is going to be our next row. It's going to be a 1 and a 1. Our rows are always going to start with a 1. They're always going to end with a 1. Okay, then I'm going to go here. I'm going to go 1 here, and I'm going to go 1 here. But we need to fill in this space right here because this one's going to have 3 numbers. All right, the way that you get that number is you take the 2 numbers above it, which are a 1 and a 1, and you add them together. 1 plus 1 is 2. Okay, the next row is going to start with a 1, it's going to end with a 1, but we need 4 numbers in this row, so we're going to have to fill in 2 spots. So the way that we're going to fill in these spots is we're going to add the 2 numbers above. So to fill in this first spot, we have a 1 here, and we have a 2 here, and we're going to add those 2 together. 1 plus 2 is 3. And to get the next spot, we are going to take the 2 numbers above it, which is a 2 and a 1, so they add together to give you a 3. All right, and we're going to continue this pattern for a couple times. Okay, so we're going to go to the next row. There's going to be a 1 here, there's going to be a 1 here, and we're going to have to fill in 1, 2, 3 spots. All right, we're going to do that with adding the numbers above it. So to fill in the first spot, I have a 1 and I have a 3, which add up to 4. All right, the next spot, I have a 3 and a 3, which add up to 6. And the last spot, I have a 3 and a 1, which add up to 4. All right, I want you to continue this. Let's see, we're going to go 3 more rows. All right, so there's 1, there's 2, and there's 3. All right, you can pause it if you want to fill it out and come back and see if you're right, or you can just fill it in while I'm filling it in. All right, so the next spot, I'm going to have 1, 2, 3, 4 spots. All right, to get this first one, add the 2 numbers above. 5, 2 numbers above, 10, 2 numbers above, 10, 2 numbers above, 5. All right, and here I'm going to have to fill in 1, 2, 3, 4, 5 spots. Numbers above, 6, 15, 20, 15, 6. And this last one, I'm going to go 1, 2, 3, 4, 5, 6 spots. Add these together. We're going to get a 7, 21, 35, 35, 21, and 7. And if you notice the numbers, they're symmetrical of each other. We got a 7 on the left, a 7 on the right, a 21 on the left, a 21 on the right. Okay, now what I want you to notice, I'm going to kind of sneak this down. When I compare this to the notes that we did the other day, I want you to look at this problem. Do you see the numbers 1, 3, 3, 1 anywhere in that triangle? And you should. There's a row that says 1, 3, 3, 1. All right. Do you see a row that has a 1, 4, 6, 4, 1? And you do. It's in the row right underneath it. All right. How about a 1, 5, 10, 10, 5, 1? Yep, I see that row right here. All right. And what about this last one? Do you see a 1, 6, 15, 20, 15? There it is right there. Okay, so this is called Pascal triangle, and we can use this to get our coefficients when we expand a binomial. But you have to know what row you're going to use. Okay, so what I want you to notice, well, actually, we're going to label these rows first. Let me get a different color. All right, we're going to label these rows. Let's go with that one. And when you think about things being in rows, if you have one thing, is it in a row? No. In order for things to be in a row, there has to be at least 2 items in order for them to be in a row. Okay, so this one right here is row 1. All right, one thing does not make a row. So the top of the triangle is not a row. The second one down has 2 things. 2 things can make a row. Now, if you want, you can call this row 0. Okay, and then we're going to go down from there. This is row 2. This is row 3. And we could have continued this triangle for a long time if we wanted to. All right, row 5, we did it all the way to row 1, 2, 3, 4, 5, 6. We went all the way to row 7. 1, 2, 3, 4, 5. Oh, wait a minute. Yeah, 7. Okay. Here's how you're going to determine what row you're going to use. All right, so let's look up here at problem number 3. See how this problem number 3, oops, let me get my pen here. See this problem number 3? It was to the 4th power. We'll look at row 4. All right, row 4 is right here. Those are your numbers. 1, 4, 6, 4, 1. So whatever power it's raised to, that's the row that you want to use. Okay, so we are going to expand, I think just one, using Pascal's triangle. All right, so let's say that we had 3x plus y, and we raise it to the 4th power. Okay, what that means, if it's to the 4th power, is I'm going to have to use, oh, sorry, that got a little too close. Use row number 4. Okay, so when I go and I look at row number 4, I'm going to take those numbers and they're going to be my coefficients. All right, come on, close up. All right, so here's row 4 has a 1, a 4, a 6, a 4, and a 1. And we want to leave space in between there so we can add things. All right, because this one is positive, that means everything, when we expand this binomial, is also going to be positive. Okay, inside your parentheses, you have a 3x and a y. We have to put them in that order. Now, we're going to put a 3x in the parentheses because the 3 and the x have to stay together. So everybody gets a 3x and a y. All right, last thing, we got to put the exponents in. Now, this was, we don't have a combination to look at to put of our exponents, but this was raised to the 4th power. So our first exponent will be 4, 0, then 3, 1, 2, 2, 1, 3, 0, 4. All right, here we go. And I'm going to move this up a little bit. We're going to simplify this. So I have 1 times 3 to the 4th. Remember, the 4 goes both places. It goes to the 3 and the x. 3 to the 4th is 81. X to the 4th. Y to the 0 is 1, so it's gone. Okay, plus 4. 3 cubed is 27. X cubed and a y. All right, plus we have a 6. 3 squared is 9. X squared, y squared. Plus 4. 3x to the 1st doesn't change. All right, here I got 1. 3x raised to the 0 power is 1, so it's gone. And then I have a y to the 4th. And all we have left to do is go ahead and multiply these together. So we get 81 x to the 4th plus 108 x cubed y plus 54 x squared y squared plus 12 xy cubed plus y to the 4th. And we have expanded this binomial using Pascal's triangle. So on the worksheet that's next to this on the video, go ahead and at the very top of your paper, where you're going to do your work, go ahead and build Pascal's triangle on the top of your paper and then expand the 4 problems beneath it. All right, text me, call me, email me if you have any questions. Miss you guys, and I hope you and all your families are doing great.